Hello and welcome back. Today I have the FeelTech FY6900 and I already had a review about this one, just how to use it, and I still think it's nice. There is one thing, and because I use now lab reference for everything, so and there is no external input to put a reference. I already found that there is a little oscillator inside here. It is below the cables. It is, well, I will zoom in on that later. It is 10 megahertz, so we should be able to make an input for that. Also, the problems that the former models had with the power supply. Some people said they had 25 or 50 volts on the connectors. They solved it here in this model by just putting a earth connection, so it's less floating. But then they use this little wire that is absolutely not rated to do so. So we will put a bigger wire there. And I found another interesting video. I think it was from a German guy. And instead of just replacing the whole power supply on his, that was the type before, I think the 6800, he just, this Y capacitor right there, he just took out, and he took two other Y capacitors and put them to ground, to the earth connection. So first I like to see how much voltage I have here, and then maybe I also do that modification and of course replace this by a proper wire. And yeah, first we're gonna see if we can measure on the oscillator which pin is what, and then we add the B and C connector in the back and make it switchable. To open it, there is only one screw in the bottom, and you will foil your bonnet, of course, but I don't think you can afford sending it back, so it doesn't matter in the end. I have this special tools, and it works great to open, because there is one here in the middle, it's already open. There is one here on the side, loose, one here, and then it's loose. So that's how you open the whole thing, and you make no scratches. Now it is completely open. I could still switch it on. And if we look right here, we need to be careful here about the right side, because this is open. Here we have the little oscillator, and if it wants to zoom in correct, oh yes, beautiful, you can see it's 10 megahertz. So I'm just gonna measure some voltages and see, and to see which is the output pin. So okay, I found out where all the pins are. The pins are power, ground, and signal. So what I'm trying to do, I wanna inject a signal here on this leg. So it is only 4 legs. So maybe I will just try to desolder and then put the oscillator straight up, and then I can put the switch in the pins between. And I just connect the power with a straight wire, because this oscillator I can continue to run. I don't mind too much. And yeah, then with the switch you just use the external input or the oscillator input. So, but it's all very small, so I need to be very careful not to break a trace, or I just need to see how I do that. I do have a heat gun, but I never did this before, so I hope I don't completely ruin the board by doing so. And well, that is hot, so I try to heat. See if it moves. Oh, the cable is a bit short. This is not ideal, I think, but let's see. Yeah, it moved. Oh. Yeah. Okay, it actually went quite well. Okay, well, the rework station also comes with this tiny point, so I tried to clean up a little bit the pads. What I'm thinking of doing is just put the oscillator straight up like this, and then of course I need to put a little wire from this pad to here and here to here, and this one is going to be switchable, and I think then we have the shortest connections. Oh, it does look I was able to put the oscillator back in its place with the two legs up. It does not look necessarily very sweet, but I think it will work. I just need to see if it is short circuiting on the housing, but I don't think so, because that tilted a little bit forward and then the housing is touching the plastic. So, but I will measure between the housing and the legs. And now we're gonna connect the ground pin, and I will just put that on the pad where it was. Yeah, it's all very small. Here is the ground pad, and then I'm gonna connect it to the thing right there. I need a microscope, I think. And let's see if we can do that. So I put a little, yeah, right there on the bottom, and I will not too much. Besides that the ground pin is now connected, it also creates support so it doesn't fall. So it's just really stuck, and it seems to be soldered well. So let's see if we can put the signal pin. It's going to be very tricky now because there is not too much support. The thing is just the oscillator is just flying. And yeah, so what I'm going to do, I'm gonna put here a BNC and a switch, and then we can switch from the external here, or we just make a connection between these two. No? So then it's internal, or from the we have the two holes, and yeah, we can put now the switch and the BNC through it. Here it is, BNC connector and the switch, and then we can just switch from internal to external. Okay, here it is. I will put 50 ohms just to get to the impedance, and I will put 1 N as a DC blocker. Well, let's see if that works with the DC coupling and the 50 ohms. So I'm gonna put that in, and then I should have on the middle pin, let's put this to ground, then on the middle pin, because we did switch to the external, I should have then yes, 10 megahertz exactly, so it seems to work fine. Look, I put there, the signal just goes through the cap and then to the switch. Well, that seems all very nice, and also from the inside we have enough space to go everywhere. Okay, well, I would have liked to use this coax cable to connect it, but it is not that flexible. And also I notice I will put too much strain on the contacts on the PCB board, and I remember seeing in my HP counter here that they also use just little wires, because well, 10 megahertz it's almost LF, if you would say. So if it's short enough, it will probably not be a problem. Here we have the switch. As you can see, the switch switches between just connecting the oscillator, or when it switches to the middle pin, it just goes here through the C and then to the board. So that's how we switch, and it actually does look very nice. So let's see if it still works, if I didn't make short circuits. Okay, I put it back together again, so I need to see if it still works. I switched it to internal, because of course we want to first check internal, if it still works, if it still starts. It does start, so I think it's also the processor that runs on the same clock. So, but let's see if we put signal. Channel 1 should be, I don't know if it does 10K, very low power. Yes, so that still seems to work. Let's see, 10 megahertz. Okay, well, that looks nice. Now let's see if we switch, because it doesn't say 10 exactly. I will show you later. So now we're gonna switch onto the external, and I think I will switch it off just to be sure that it doesn't go all crazy if the processor also runs on the same clock. Okay, here we go. It does start or not. No, there is no output. Okay, it does work again. I just needed to power it off, but I also noticed I forgot the ground wire, because of course I can put the 50 ohms, but it's completely floating. So I also connected the ground to the ground of the other BNC right here. So, but I have now a signal of 10K. I'll switch it off completely. Then go to the external reference. Switch the switch over. Power it on. And we have a signal. We have a signal. So, and it is 10.000000. That is what I wanted. So it seems it's working. That is great. So let's put 10 megahertz. This one down. Boom, book. And now we should have 10. Yeah, this is exactly 10. Look at this. This is on the external reference. Let's see if I can just switch over, or it will just totally crash. No, it will crash. Okay, I really need to power it down. I'm going to do that. The processor also runs on the same clock, so I hope I didn't damage the memory. Let me go back to 10 megahertz again. Here it is. Now you see this is his internal clock, which is not exactly 10. That's the whole thing why I wanted to do this. And now I will switch over. Power off the device. Power it back on, and here we are on its own on the external reference. This is cool. This is what I wanted. There was one other issue, and I saw a lot of that on other videos, especially on the formal models of this one, that it didn't have an earth connection. It just had a 2-wire from the mains, and this one does have 3 because it has earth or ground. And the issue was, if you put it on AC, you just hold one, and the other one you put in one of the BNCs, and then you see now we have 2 volts AC. That is not bad, but you prefer to have it a lot lower. And but the other models had above 20, sometimes even 40. That was dangerous. I still like to change the ground wire, and I think I also make the other modification. So what I did, instead of putting that little tiny wire that should be ground, I just put it directly on the board, and then instead of the Y cap going from the primary to the secondary side, I put another one in. The original is on the secondary, and I put a new one. Here you can see it's now 2. I will put the schematic later, and they are both to ground. And the good thing is doing that, because I should have not necessarily do the the primary side, the hot one. I don't need to do that, but it's also nice because if you somehow lose your ground, then it just steps over, and you can see in the movie, I will put a link. Well, let's see if it works, and it at least improved. Well, the earth wiring looks a lot better, I would say. So now we have proper earth connection. Let's see if it doesn't blow any fuses and if it starts. Yes, it starts. Is it still working? Yes, it says 10K, but let me see, 1, 10 megahertz. Well, it's the more or less 10 because it's running on internal. And do we still have, it's not fair, unhook it, how much voltage we have? We have 360 millivolts. I would say this is a success. So from 2 volts we could even cut it better, and now it's 330 millivolts. I would say success. So here we have it, our modification. It's all back together again. Looks nice and sweet, like nothing happened. Only an extra switch and a BNC in the back. So this is how you can put an external reference to your signal generator, so it's more precise. Because this one actually goes up to 60 megahertz, so you can use it for CB if you want. But and it does FM modulation. So, but then you need it to be precise, so external reference. That's it. Thank you for watching, and I hope to see you next time.